Okay. And yeah, I need to let him multiple. Okay. And then let's get this over here so that everyone can see. Okay.
And you
All
got the
right.
share on, right?
Yes.
Okay, I'll go ahead and introduce you, James. Thanks for waiting. Today we have Dr. James Flaten, who's the Associate Director of NASA's Minnesota Space Grant Consortium, a higher education program whose goals include promoting interest in space science and space exploration. Though housed in the Aerospace Engineering and Mechanics Department at the University of Minnesota Twin Cities, Professor Flaten's academic background is actually in experimental physics, and he has also taught many physics, astronomy, and basic engineering classes in the past. He enjoys using ballooning, both stratospheric free ballooning and lighter than air RC airships, high power rocketry, quadcopters, and robotics as relatively low cost means of giving students hands on experience building and operating NASA aerospace related hardware. And with that, I will turn it over to you, James.
Okay, so thanks so much for having me. Um, I don't need to tell you about eclipses. Basically, I'm envious that you got one and I didn't, but I came to you, and that's actually, I think, why I got invited to give this talk is so people could hear a little bit about my experiences, especially flying balloons during the recent, as in 2 years ago, solar eclipse, total solar eclipse that came right over the top of you. Let me share my screen, and I think. I won't even bother sharing sound because none of the things I'm going to show you have sound that's important. Okay, very good. So, you know what? Again, I'm James Flaten, and I work with NASA's space grant program. It turns out there is a space grant in every state, and so you may be involved in your space grant. And if you're not, there definitely are people near you who are. And I just want to tell you a little bit about the Nationwide Eclipse Ballooning Project, NEBP. And this actually started for the eclipse in 2017. I was involved in that. And then we collected different teams in actuality to do stratospheric ballooning so as to observe the eclipses in 2023 and 2024. The 2024 total solar eclipse came right over the top of you. The 2023 eclipse missed you. It missed us in Minnesota too. But I traveled to both of the eclipses with students um, and had a great time. And so, thank you again for your hospitality when I was in your area. And I think I will probably not take all of our time. In fact, even though we're starting a little bit late, in part because I'm anxious to have a discussion about what you see in this project and what you're trying to accomplish, and if there's anything that I can help you with or that we could collaborate on or at least coordinate on. So, here's a bunch of the people that were involved in the Nationwide Eclipse Ballooning Project, NEBP, at least in the 2023-2024 version. And so I'm going to start right off with the best footage I have. Why not? So first of all, let me just set the stage. This is a 360 camera. This is at about 80,000 feet or so. Actually, it's about 60,000 feet in this moment, and it will get to 80,000 feet in a moment. I haven't started the video running just yet. But just kind of to set the stage, this camera has two lenses, which point in exactly opposite directions. With software, you can stitch this together and make it look like it's 360 and wear headsets and stuff like that. But here I can see the sun in the right-hand lens, the balloon above me, and then there is also payloads both above and below me, me being the camera which is attached to a nearby payload on a selfie stick. If I run the video, the first thing you'll notice is it wiggles a lot. This is very typical for balloons of this sort, weather balloons. But what we did on this particular flight, which was special, is we vented the balloon, so we stopped it from ascending. And so this is 60,000 feet, and now this is 80,000 feet. So I just cut forward in the video, and notice it is still running video. It still is moving a little bit. But in actuality, this is astonishingly calm for video taken from this size of balloon. It's possible to do this with the massive balloons that are the size of a stadium. It's very unusual to be able to do this with a balloon that's the size of a small house, frankly, or a tree, maybe 10 meters across or something like that. In this view, at 80,000 feet, I can already see the eclipse shadow. It's about 150 miles away. It's coming over the horizon. Hopefully you can see my cursor. This is the eclipse shadow coming at us at about 1900 miles an hour. So the people on the ground, including yourselves, if you were there watching for it, are noticing the sun is getting a little tiny bit dimmer, but this is still some minutes before totality. But I can already see it from this vantage point. Of course, I wasn't there. It was just the cameras. Right now, I'm 1 minute into the video. I'm literally going to jump to 2 minutes into the video. So this is about 60 seconds later. And now here is the eclipse shadow. It's moved to the other side. It's definitely gotten closer. The sun still looks pretty bright. It's still overexposed, but things are happening. Let me jump another minute forward. And now I can really see almost the entire shadow. So the shadow is 100 miles across or so. The speed of the shadow at this point in time, it does change a little bit depending on where you are in the track, was in the vicinity of 1900 miles an hour. And so what's going to happen is the shadow is going to reach the balloon. In fact, let me just forward it to another minute forward. And now the shadow is very close to the balloon. I'm seeing shadow below me. And if I watch, you can literally see the sun go out. Now, it turns out you can see the sun go out from the ground too, but this is just the coolest video ever as far as I'm concerned. Watching the balloon and watching the sun, and the sun is just diminishing, diminishing, diminishing. Now, this is not a telescope. In fact, this is a very, very, very wide angle view, and so this is not the best footage looking at the sun and looking for details. But in this particular case, I can see the entire environment. I see the sky is black in the middle of the day. I can see the glow of the sky. We're basically above the glow of the sky. Now that we are in the shadow, the balloon is being illuminated solely from reflection off of the Earth because there is essentially no sunlight reaching us from the sun. Of course, what you do see in this particular part of the sky, that's the corona. Okay, so in other words, there is something up there, but the surface of the sun is fully covered. Again, this is the steadiest video, as far as I know, that's ever been taken from a balloon of this sort of a solar eclipse. The reason I'm pretty confident about that, in fact, is because there were 50 teams working on this project, about 30 of which were doing this kind of video work. And we got together for a conference after the eclipse and we compared videos. And frankly, we had the best video. Um, Many other teams did get video similar to this, and using the camera to settle the video down, which is post-processing. I'm not saying cheating, but that's a different way to settle the video down. They could get video that looked nice, but we didn't even have to post-process it. This is raw footage. On the other hand, you have to be careful what you wish for. And the reason is, if I look down here, here is a payload dangling from the 360 camera payload up here. And it's got a flashing light right there. That flashing light is a GoPro camera, which is pointing up and could see a third of the sky or so. And it was pointing in the wrong direction. And we settled things down so thoroughly that that experiment failed. And the reason it failed is because literally the eclipse went by and the camera was pointing at the wrong part of the sky. So I was tickled by this footage, but in actuality, the people, my students who built that particular box were, let's just say, a little bit less enthusiastic. Um, so where are we in my timeline here? 6:40. I'm just going to push this forward to about 7:40. I'm pushing it another minute forward approximately. It's running in real time. And so now the shadow is almost entirely beyond me. I can see it below, but almost all in the left-hand lens, which more or less means that the edge of the shadow is about to reach the location of the balloon. It's a little bit hazy, but I'm definitely above the haze. And the haze actually helps me see the contrast, although it doesn't help the people on the ground see the eclipse as well. But it was an okay day for those of you who were there, you know that. And look at the sun, here it comes. So right now it's like 99.99% covered and it's already too bright for the camera. And so the camera is getting overexposed. In fact, this is one of the things that I think about when I look at the sun through solar glasses or I look at footage like this. It's like, wait a minute, is the sun really that tiny? And the answer is yes, it's the same size as the moon. It's 400 times farther away than the moon and 400 times larger than the moon. And so the moon just barely blocks it out for a few minutes at a time if you do it just right. Um, But in actuality, it's almost always, on photographs at least, overexposed, and so it looks too big. And there goes the shadow. And it's already well beyond us, maybe 100 miles or more beyond us already, and it's going to go over the limb of the Earth. And so from this vantage point, different from on the ground, we were able to experience the eclipse, or at least see fractions of it, from well before totality to well after totality. It was not just a totality event. So there it is. That's the good footage. Now let's talk about some details and how we did that. Um, can you at least say boo so I know you're hearing me? Todd, are you there? I'm just going to stop for a second just to make sure that we're on the same page here. Are we good? We're good. Okay, super. Back to sharing. When I share, it turns out I can't see you at all, and so I want to make sure that you're still with me. Here we go. Okay, some general comments. Eclipses, there's typically a solar eclipse somewhere in the world every second year, I think. They often come in pairs, so this was a pair of eclipses that were 6 months apart. This is not unusual. Um, The first of these eclipses was in October of 2023, and it was annular. So annular in this case means ring. So this was a ring of fire eclipse. The moon, which is not exactly the same distance from the Earth at all times, was slightly too far away from the Earth to completely cover up the sun. The moon was too small, frankly. And so that was an annular partial eclipse. All eclipses are partial, I guess, but that was an eclipse that never quite reached totality. And then the total solar eclipse, which came across the top of you, the reason there are lights along that path is because, frankly, lights do come on when it gets dark if they're automatic. So that was indicating a total solar eclipse. That was in April of 2024. And let's just talk a little bit about, why is my screen not, yes, okay. Just having a hard time getting my slides to forward. The organization of NEBP, the Nationwide Eclipse Ballooning Project. This was organized by space grants. There is space grant in every state, and hence every state had access to this program. Not all states chose to be involved. A bunch of states actually chose not to be involved in what we did because they were doing their own thing. Interestingly enough, I think Indiana was in that category. Indiana did a bunch of things for the eclipse in ballooning, but they did not feel a team in our particular project. It turns out that we decided to try two different things. We decided to try video streaming and taking video of the eclipse. That was the part that I was on, the side that I was on. We called that the engineering side. I prefer to call it the video side. Okay. And then there was the atmospheric science side, which I prefer to call the radiosonde side. And a little bit more about what the engineering teams, the video teams did, and what the atmospheric science teams did. I'm more familiar with the video side. But this is an organizational chart, which basically shows that we have teams in many states. In fact, there were a total of 53 teams, and some teams had more than one institution involved. And so there were 75 institutions involved in these 53 teams, over 800 students. And we chose a few of the teams, 4 of the atmospheric science teams and 5 of the video streaming teams, the engineering teams, to be leaders. And so I was one of the leaders, a pod leader. So here I am in Minneapolis, in Minnesota, and I was assigned a pod. And the pod had a team from South Dakota, a team from Nebraska, a team from Iowa, a team from Texas, and a team from Tennessee. Those were the teams assigned to my pod, and then there was my team as well. So my role in part was to get those teams ready for the eclipse and hopefully ready enough that they didn't have to bother me on the day of the eclipse because I was busy trying to do my own flying. You'll notice that there's very little relationship between this map and the previous map. And the reason is the previous map, this is where the eclipses go, but this is where the teams came from, which more or less means that almost everybody had to travel. Some people had to travel a long way. I traveled to New Mexico for the first eclipse, and I traveled to Indiana for the second eclipse. Um, And so Montana, the Montana Space Grant actually was in charge of the overall project, and they were involved as a pod lead for one of the engineering pods. Um, but they were overseeing the thing, and so I was one of about five engineering teams and four atmospheric science teams, sort of the second level of leadership in this particular project. Just for the record, here's where we were. We weren't telling our teams exactly where to set up. In other words, where along the line, presumably along the line, they wanted to be. And so for the total solar eclipse, we had engineering teams and atmospheric science teams spread dramatically along the entire United States part of the track. Of course, this thing came in from Mexico, it went over Texas, it went over it went over all the way up into Canada. And basically, we had teams as far north as Maine, and we had a bunch of teams in Texas. The reason a bunch of teams chose Texas was that was the crossing point for the two eclipse paths. And so if you went to Texas, you could potentially be in the same spot and maybe be used to being in that spot for both eclipses, even though they were 6 months apart. And let's talk about these two tracks a little bit more. Okay, so the atmospheric science track or the radiosonde track, basically they flew smaller balloons and they flew a whole bunch of them and they did not get them back. This is essentially what the Weather Service does. They launch small devices that can make measurements on balloons. They track where the balloons go and they get so they know where the data came from. But in fact, the Weather Service throws away balloons over and over again every day from about 200 or so, I forget the exact number, locations around the country. It's fewer than it used to be. Won't get into that. Um, but anyway, so what the atmospheric science teams were doing is taking essentially Weather Service data on either side of a passing eclipse. So get a much denser data set. The engineering teams, the video teams, or the video streaming teams, used bigger balloons. They flew video equipment, some of which was trying to stream data to the ground, some of which was from onboard video cameras that needed to be recovered. So typically these teams didn't fly nearly as many balloons, maybe one, maybe several, but not like 30. The atmospheric science teams actually flew 30 balloons each team. So radiosonde, there were 19 teams involved. And what they did is they flew balloons, they launched balloons every hour for 30 hours. So 24 hours prior to and 6 hours after the center of the eclipse. And of course, the eclipse lasts for a few hours as a total event and only a few minutes as the maximum amount of obscuration. So their goals, and these were essentially science goals, so they were in some sense more serious. Not that we weren't serious, but more or less these radiosonde teams were trying to collect very high quality data, put it all together, and see what they could learn. And here's what they were hoping to learn. They were hoping to characterize eclipse-induced changes in the atmosphere. And they were also hoping to pin down whether or not eclipses can start atmospheric gravity waves. And it turns out eclipses can, and they have the data based on this experience and some other less large campaigns to do eclipse ballooning. I don't know as much as I should probably about this stuff other than they were flying Weather Service balloons, Weather Service data collectors, and they had people essentially from the Weather Service and academics doing most of the data analysis for them. On the other hand, I intentionally chose to be on the video streaming track or the engineering track, in part because I love pictures, and also in part because we flew bigger balloons, big enough that we could put our own stuff on the stack carried by the balloons. So this was the more creative, shall we say, version, although perhaps the less professional version. Every balloon had some common equipment, and every balloon had some student-built, independently built and tested equipment. And so we had lots going on, and we essentially gave people equipment to try a bunch of things. And not every team tried everything, and not every team that tried things succeeded in getting it all to work. But more or less, we were flying what are considered large weather balloons. They're not the massive balloons, but these are significantly bigger than the ones from the radiosonde side. Um, we did develop a vent, and so the vent allowed us to stop the balloons from going up, and that settled the view. And we expected that to happen. In fact, we didn't totally know it was going to work, and it worked really well. but not all teams succeeded in getting the vent to work. And a few teams just chose to make that optional and didn't even try it. We were trying to essentially take video and stream it to the ground. And this is actually very hard to do at the size scales and the weight limitations. And in fact, there were a lot of people that thought it couldn't be done. And in actuality, it was sort of successful. On the other hand, we did fly much higher quality and much higher resolution cameras, and those had to be recovered before we got the data back. But the 360 videos in particular were really exceptional, especially for the balloons that were vented, so they weren't swinging and swaying so much. So we collected 360 video, not streamed, but it was recovered. That was very successful for many teams. Um, we vented balloons. Some teams managed to do that. Our team did, and that was successful. On the other hand, the actual streaming of the video to the ground was, well, I'll show you some examples of it, but for my personal team, not so successful. In fact, this is kind of embarrassing to admit, but we took our video streaming stuff to New Mexico and managed to stream some video, but it wasn't during the Eclipse part of the flight. That was not great. And then we drove to Ball State, literally, and we got there and we looked in the back of the truck and it's like, wait a minute, didn't you pack that? And it's like, yes, we packed that. It's like it's not there anymore. And so maybe it fell out, maybe somebody swiped it when we stopped for lunch. But anyway, we literally arrived without our video streaming flight equipment. We had lost it. So our team did not, in fact, even fly video streaming equipment. Many teams did, and some teams, not very many, but a few teams managed to get at least some video streaming data. But my claim always was that's important, that's interesting, but as soon as you get your real cameras back, you'll never look back at the video stream data because it's so much lesser quality than the data from the actually recovered cameras. Therein is the difference between ballooning and like outer space flight. In outer space flight, you don't get the stuff back, so you have to send it down by radio, and that's a task, and that's a challenge. But in the case of ballooning, we can actually shortcut it and say, look, this is going to come down, probably not too far away, probably the same day. We can recover it, and so we don't have to work so hard to get the data, and we can get better quality data and much more of it. And then, of course, most teams, my team included, built other kinds of payloads. And so some of those were successful, some less so. A lot of the teams were rather new to ballooning, and when you're new to ballooning, things don't always work out. But even my team that had a lot of ballooning experience, we tried and did not succeed in getting everything that we tried to work. That's a nice background picture, though, taken from not one of the streamed videos, but that was definitely a still photograph from one of the high quality, probably a 360 camera, showing the Eclipse shadow. Some comments about being a pod lead. So prior to the eclipses, we were asked to try to develop and ultimately roll out things that other teams could use for common equipment. So we didn't personally work very much on the video streaming stuff. We worked on the development of a flight computer called Pterodactyl. And in fact, that was adopted and was used effectively by essentially all the teams on the engineering side. We were asked to work on a vent, and several other teams, pod leads in particular, worked on vents, and ultimately our vent did not get adopted. It did work. We made a vent that was autonomous. In other words, a vent that you could pre-program it, like go up to 80 or 90,000 feet and vent until you stop going up and then hold it for 30 minutes or whatever, or hold it till the eclipse is passed based on a clock, and then cut away the balloon and then come down. Because once you vent a balloon, it won't pop anymore. Usually you either go to pop or else you vent it, and in which case you have to have some other terminate mechanism. So we developed a vent, as did Montana, and ultimately we agreed to adopt Montana's 3D printed vent, which was much bigger and bulkier and was commanded from the ground. So they didn't have an autonomous vent, they had a commanded by radio commanded vent. And so we ultimately used their vent and did well with it, but we still continue to dabble because there's things you can do with vents. In particular, you can get longer hang times, you can get steadier flights, but it's harder because if your telemetry goes down or the autonomy goes down, you might actually lose your equipment because the balloon will not come back down again anywhere that you can possibly reach. I landed a balloon in Idaho once, and Idaho is a long ways from Minnesota. That was because something leaked. It wasn't an intentional vent, but more or less inadvertently vented a balloon, and so it didn't pop, and so it drifted away, and we were unable to recover it. We also spent a long time helping develop a ground station called Hermes. And frankly, I don't remember if Hermes actually stood for something. I think it did, but I don't know what. Um, but the ground station was for pointing the ground antennas for the video streaming. So Montana, that developed the video streaming, had their own ground station, and there were some features of their ground station that my students didn't appreciate, and so they came up with a different ground station software. And ultimately, the teams that had the hardware, about half of them, I believe, used the Montana version, Brad, and about half of them used the Minnesota version, Hermes, during the ultimate eclipses. We worked on training the teams in our pod. I already mentioned the states that were assigned to us, and we had lots and lots and lots and lots of meetings with the organizers and with the other teams, including people not in our pod, and did training activities with our pod and beyond. In fact, we even developed essentially an online course for people to learn about these things, just because a bunch of the teams were unfamiliar with ballooning, and this was not the entry-level ballooning, to be honest. Other things that we did lots of practice flights, lots of testing. We got pretty good at venting, better than most. We got pretty good at 360 video. We struggled with video streaming. I already mentioned that. And in fact, we developed some other flight computers, Paddle and Piccolo. Paddle is sort of like a pterodactyl, except it's long and skinny, so it's more suitable for rocketry. Piccolo is a bit like a pterodactyl, except instead of using a teensy microcontroller, it uses a Pico, Raspberry Pi Pico microcontroller. Um, so this came out of it that we got pretty good at developing and actually training people to use various kinds of flight computers that are microcontroller based. And we made two trips, one from Minnesota to New Mexico, that's a long drive, one from Minnesota to Indiana, that's not nearly as long of a drive. And we ended up having people in Upland and people at Ball State. I was actually staying the nights that we were in the area on your campus. We also helped with data analysis, and we did a conference, an online conference in between the two eclipses. We called it the Between Eclipses Remote Conference Burke, named after Burke. I won't go into that. One of the people who was involved was named Burke. And then, of course, there was the AHAC Academic High Altitude Ballooning Conferences in 2024 and 2025. Both of them were after the eclipses, and these were times that we got together and shared footage and shared stories. So this is what it looked like. We flew 3 balloons, and as far as our results, we got and other people got lots of good data from these kinds of balloons using our pterodactyl device. So the pterodactyl actually sensed many more things than the weather service balloons did, but we only flew 3, and we flew them all at the same time instead of 30 over 30 hours. But we were trying to collect data to supplement the radiosonde side. Of the 3 balloons, we put a vent only on one balloon, mostly because we only had one telemetry system to command it. So the nearest balloon in this particular picture was the vented balloon. Um, we set up Hermes at Ball State. On the other hand, we didn't have a video streaming payload in the air, and so Hermes was pointing things at the balloon as it flew by, but it was not actually getting video stream data down. So we did not get video streaming done at all, at least in the second of the eclipses. We did some, but not very effectively in the first one. And then 360 video, we got quite a bit of footage from all 3 balloons. I showed you the data from the vented balloon because that was the one that settled down the most. A little bit about pterodactyl. So pterodactyl is an acronym. It stands for Payload to Enable Recording of Data and Communication Telemetry While Lofted. I came up with that myself, and I didn't even use AI. But we basically rolled this out, tested it a lot, and then gave all the teams parts and instructions, and they built their own pterodactyls, and they flew them. And this was quite useful, and it turned out that Montana also handed out a flight computer, except theirs was already pre-built. And so pretty much everybody had 2 flight computers, and ours was the one that they understood better because they had to actually assemble it themselves. So this particular flight computer was based on a Teensy 4.1 microcontroller. It had a GPS so as to stamp the data. It had a pressure sensor. It had an IMU, which gives you roll rates and, well, acceleration, sort of. It gives you gyroscope data. It gives you magnetometer data. It has a tiny OLED screen, so you can actually see what it's doing, and at least if you're on the ground, that's good for troubleshooting. It had flashing lights as indicators, also useful on the ground. And then it had a short-range XB radio, which allowed it to communicate with other payloads on the same stack, but not talk all the way to the ground, although it is possible to use such a flight computer with different radios to talk to the ground. It had two thermometers, one that was measuring the temperature in the payload. It was basically on the printed circuit board, so that was the internal thermometer. And then another thermometer in this photograph, which is on a white cable, which would dangle outside of the payload and give you an opinion about what is the external temperature. Um, and then for the most part, we powered it either with a 9-volt battery or with a 3.7-volt battery. In this particular photograph, it shows the blue 3.7-volt battery. And then our sensors only occupied some of the capability of the microcontroller, so we had terminal blocks which allowed people to tie other things, other sensors into the pterodactyl if they wanted to. So this again was used by all the engineering teams. Here's the vent. And so it's a 3D printed vent. Basically, here is a nozzle for inflating the balloon with helium. Here's a nozzle for inflating the balloon with hydrogen. In the middle of the Eclipse project, helium suddenly became very hard to get, at least at my institution, and so I switched over to hydrogen and haven't gone back. In fact, but we had vents that were able to accommodate either kind of hookup plumbing. And then this particular vent, what we did is right here is an insert that would go into the neck of the balloon. And then here is the vent itself. And this was a test of a Marmon band that essentially held the top to the bottom. And it turned out that on the first eclipse, we did sever the connection point, but it had frozen together. And so, in fact, the balloon didn't separate properly and it came down very slowly instead of letting us tumble out of the sky. And so, in between the two eclipses, we added a spring-loaded Marmon band. And so, this particular video here just shows me reaching in with the scissors, cutting the string that's holding the thing together, and watching the spring release the Marmon band. So that was more effective. And so we used that and have continued to use that for releasing the Marmon band and making sure that we can have like vacuum grease or something on it that doesn't freeze up and allow us to have cleaner separation of the balloon, which flies away, and then the vent, which falls down with the rest of the payload. Here are altitude versus time plots for the two eclipses with the totality on the right-hand side indicated and the maximum obscuration on the left-hand side indicated. If you look at the right-hand side graph, this is what it should have looked like. Ascent and then eventually sort of leveling out, in this case, just shy of 80,000 feet. Okay. And then sometime after the eclipse totality had passed, then termination and coming down fast by parachute. If you look at the right-hand side, you see going up and you see leveling out, and then you see coming down not very fast. That was because we couldn't get rid of the balloon. We vented the balloon enough so that it wouldn't hold us up anymore, but we didn't manage to actually let it go of it, and so we kind of came down by balloon instead of coming down by parachute. But in both cases, we managed to keep the thing from going up, and hence we had good photography, especially on 360 cameras, and we managed to float it to reach some sort of a pretty level altitude. In the case of the first eclipse, it was just over 60,000 feet. We were a little delayed on getting that one off the ground, so we didn't get up as high as we wanted to. The second one, it was closer to 80,000 feet. That was about what we were planning for. And we did manage to level it out before the eclipse reached its peak. So this was well timed. This is very good result, shall we say. A little bit more about Hermes. So basically, here's a picture of the antenna and Hermes and the total eclipse in the background. And if you notice, the antenna is not pointing at the total eclipse, which is completely correct. The antenna is pointing at the balloon, and the balloon is not in the direction of the eclipse. The balloon is in the sky, but it's not in the same direction as the sun. So this particular screen, they implemented a bunch of things and they got ready to implement and didn't quite get fully implemented a bunch of things. So for instance, it was able to do venting. It was able to show the video stream on the screen. It was able to show a bunch of information, including where exactly you are and how far away is the balloon. And you could plot things and you could draw maps and you could do predictions. And so they had great plans and they managed to get most, but not quite all of it done. And then the student who was working on this graduated. So right now Hermes remains quite functional, but it was never quite as cool as they were expecting it to. But if I take a closer look, so this is Ball State, yes? I'll take that as a yes. I think your microphone might be turned off. But anyway, so here was the setup on your campus. And with two different antennas. One in the background there was for the video streaming, and then the foreground one, which was actually pointed by hand, that was not an auto-pointed antenna, is now, it's not, there's no balloon in the sky at the moment this picture was taken, but that was going to be pointed by hand and get some telemetry data down from a different flight computer. So, and then I also see in the foreground on the left-hand side is a small telescope. Um, So here's what the screen looks like. Here's when the thing is being used perhaps in a car. Also often, or typically we wouldn't use it in a car. We'd set it outside. And if I just talk through the screen, here is essentially an altitude meter that shows going up and coming back down. And so these are some indications of, if you're at this altitude, this is about where you might be floating or possibly bursting if you're not doing a floated flight. This tells you which of the various radios you are currently attached to. This allows you to manually tweak the pointing if necessary. This tells you what are the numbers and what are the offsets. There's clocks, and this is a place for the video stream to be played on, although this is clearly not the video stream from a balloon. This happens to be from the International Space Station. So this had a lot more features than the original telemetry that came from Montana, which is why a bunch of teams chose to use it, although it was under development even up till the last minute, which is not always ideal, but it was a useful device and continues to be a useful piece of software. A little tiny bit about video streaming. And so for the teams that got good at it, they were able to sometimes get streams of video from two different cameras up to 100 kilometers away, although sometimes 100 kilometers was not enough. And so this is just a screenshot from one specific video stream showing an eclipse in the distance. But as you can see, the resolution is poor, at least compared to what we were able to do. If I click on this link here, so this actually is sped up, but this is the footage that came from one of the cameras from one of the teams. And so that's as good as it gets, and that's pretty good. On the other hand, if you scroll down here, you'll actually see a lot of different streams from a lot of different schools. And frankly, some of them show an eclipse and many of them don't. And some of them show maps and don't show the eclipse at all. And in fact, I think my team isn't even listed because we didn't manage to stream anything on the day of the eclipse. But if you want to, you could potentially take a look at this live stream archive and learn what people were able to do. And in actuality, it was hard. This, on the other hand, this is very cool. So here's one thing that one can do with steerable video. Let me see if I can get this to run without any advertisements. Maybe I can. Here we go. Okay, so this is a 360 camera, and a nice thing about the 360 camera is that you can post it so that you can drag it around. And so I can look up at the balloon, and there's the sun is up there. Oops, keep it running. And I can look at the shadow that's in the distance, and I can look straight down, and I can see one of our other payloads dangling down, for instance. So this is a nice feature of these 360 cameras. It's possible to post the data in this way. In fact, just for fun, let me look up at the sun, and then let me just forward this until I see the sun gets covered. So let's see, getting closer, getting closer, getting closer. There we go. So now the sun is covered, which pretty much means if I look down, there should be a shadow below me, and there is. Okay, and then there's still that payload down below. I'll tell you a little bit more about that payload in a moment. But anyway, so this is nice footage, possible way to show stuff. And so this was from a 360 camera, but again, this was not streamed footage, and it was post-processed so that you can drag it around. Here, in fact, are some still shots from what I already showed you. So I won't show it to you again, but basically showing the path of the eclipse shadow in raw format. Okay, so raw format, I sometimes call it the double bubble format, where you can see the two independent lenses. And this is approximately what it looks like. Here's a box, here's a selfie stick, here's the camera. It's not that far away from the box, but one thing that's quite clever is the selfie stick actually goes in between the two lenses, and so it doesn't show up in the video. In some sense, it's almost like the software hides the selfie stick, so it really looks like you're out there in the wild and not connected to anything, which is a very cool effect. In fact, let me just show you. One of my students just was playing around with the software that allows you to stitch this together. And so here he is. He's dragging it around. He's zooming it in and out. He's looking down. This is available to you if you use the software that comes with the camera. And so if you pay big bucks, well, $500 or something for the camera, the software comes for free. And so here he is looking at the eclipse, looking at the shadow, and able to, in this case, take a pretty close look at the sun. So he's going to zoom in on the sun. And so one of the downsides about a 360 camera is that since it has such a wide view, you don't see details. But in this particular case, with some of the zooming features, he can in fact zoom in and you can tell that the center of the sun is covered, although it's not exactly, it's not a telescope. That's for sure. But this is called Insta360. The camera is called an Insta360, and then this is the Insta360 Studio software. I will admit, I literally never installed this software on my computer, and so I don't know how to do that, but I've seen my students do it. They also like to show this kind of footage through 360 goggles. Very quickly, just a couple other things that we tried. So these were not common across all of the teams. In that footage where I was dragging it around myself, you saw this payload below. It had sort of a bubble on the top, and underneath the bubble was a Pixie camera, which is a machine vision camera, which can be trained to identify things. In this case, we tried to train it to watch the sun. We were a little unclear what would happen when the sun went away. And then it was on a platform, a lazy Susan more or less, so that it could tip up and rotate so as to find the sun. And then hopefully, this was the plan at least, point another camera toward the sun and get higher quality photographs with a more of a telephoto camera. Didn't, in fact, work very well. We continue to work on this payload. And the reason is, if you were able to have something that could point very accurately at the sun on a balloon, and then you put something in front of the camera to cast a shadow on the camera, and we're above the glow of the sky, this is called a solar coronagraph. In fact, you can make yourself a synthetic eclipse. This is done actually by solar monitoring spacecraft, outer spacecraft. I'm not sure I've ever heard of anybody pulling this off on a weather balloon. And so this is something that we continue to play with because I don't really want to wait another 20 years for the next total solar eclipse to come to the United States. I want to see if I can get some pictures of the corona myself, at least get my balloon to take a look at the corona. Here was a payload. I already mentioned this. It was dangling down in the footage I showed you. Remember that flashing light? This particular payload had a bunch of light sensors and detectors looking for visible ultraviolet light range A, ultraviolet light range B. And unfortunately, this more or less failed, not because the payload didn't work, but because we were so good at settling down the flight that the payload was not looking at the sun. And so it did not see the light decrease and come back up. If you look at the video footage, you can say, you know, that looks a little weird, but there's no sun in view, and so you really don't have firm evidence that the sun got eclipsed. One last thing that we flew, and this was essentially a thermal imaging payload. Unfortunately, the flight computer in this particular case didn't work, and so in some sense, we were stretched thin. We were trying to do video streaming. We were trying to do 360 cameras. We had all of these other payloads. We only had 6 people, and this was a little bit too much for us. And so ultimately, this is something that wasn't quite ready to fly, but had a bunch of sensors, and what those sensors were mounted on a side of the box that was angled so as to point toward the sun. This was not on a vented flight, so it was in fact rotating, and it should have been able to see variations in light, but we had to return to this after the fact, and of course, after the fact meant we flew it, but not during an eclipse. That's what I've got. Hopefully that was interesting. I'm happy to take questions about this project, eclipse ballooning. If you look at this particular photograph, you look right up here, this is in fact a rather nice picture that shows some detail on the eclipsed sun. But if you have also questions about experiences on ballooning or ideas of things you have done or things you want to do, I would be happy to do my best to, well, let's just say engage in a discussion.
Should be.
Can you hear us now?
I can hear you now.
All right, great. Okay, any questions? Oh, like, uh, yeah.
No, okay. So my question is, you launch these things, they go up, they stay at a certain altitude, then they come down. Along the surface of the Earth, they're traveling some linear distance. How far are they traveling? And when they go up, how do you know where to launch from so that you go through the shadow at the right time? In other words, how do you know where to launch from?
Okay, fair enough. First of all, when I'm doing regular ballooning, the thing I pay the most attention to is where it's going to land, because I don't want to land it in Lake Superior, and I don't want to land it in heavily forested areas. But it doesn't really matter. I'm not trying to intercept anything specific. For an eclipse flight, it's tremendously important that you get it up in the air and make sure it's at
Be
the right
sure.
spot. Let me do the following. Let me, one moment. I'm just pulling up. I will share my screen in a second. So the nice thing about an eclipse is it's well predicted. You know exactly where it's going to be, and you know exactly when it's going to be there. Um, And frankly, the difference between the eclipse map at 80,000 feet and on the ground is it's not zero, but it's pretty trivial. And since the eclipse shadow is wide, kind of anywhere in the middle, if you don't hit right in the middle, then you won't get as many minutes of totality. That's true. But if I go to back to sharing, so here is some data that I have from this particular flight, and here are predictions. Um, and so this was our plan. So basically, we look at the weather. It was nice weather, and then this was our plan. We were going to fly out of Lebanon. We didn't ultimately do so, but I was this lake up here was annoying me. Okay, and so it turns out the key was launch it at the right time, get it so that when it's in the middle of its ascent, it's there when the eclipse comes by, which is only a few minutes. Okay, and then in this case if I hadn't vented at all, it would have burst and it would have come down and landed about here. That was the plan. Ultimately, I changed this plan at the last minute. But so one can do predictions using prediction software. The prediction software pulls the most recent weather service data, some of which came from balloons. So we use balloons to figure out where our balloons are going to go. Okay. On the other hand, let's actually see what happened. So let me see. Here is an actual track. So this is information from the actual flight. This is one of three. Okay. And so in this particular case, this is where we ultimately launched from. I moved it from Lebanon south. I forget the name of the town, I'm sorry, but I launched from the side of a dollar store. I have to say I was disappointed. I was planning to launch from a school at Lebanon and they said, by all means, come to the school. We won't be there. And then I decided, because of some things that had changed in the weather, that I wanted to launch from farther south. So I went farther south and I found a school there and I didn't tell them I was coming and I drove up to the school and they were barricaded off, literally. It's like, sorry to be critical, but my impression is that some school districts in your part of the world did not take advantage of the eclipse the way I think they should have. Ultimately, I went down the road from the school and I found myself a big building that could protect me a little bit from the wind, and I launched from the next to a dollar store. And then this is what happened. It went up, it went up, and it went up, and eventually it came down and it landed right here. And this is one of three. And so I think my other two actually went farther than this one, but this was following, not too different from, remember the prediction I had from Lebanon was going to land up here, and then I moved it south, and then it ended up landing somewhat south. So the nice thing again about an eclipse is it's predicted in advance. You just have to get good at letting things go. And this is not easy. And the reason is it takes time and it takes a lot of coordination to get everything ready to go. And even up to the last minute, we were struggling some to get ready. And so you notice that photograph I showed that had three balloons. What we chose to do is inflate all three balloons well before we needed any of them. And then we would let them go one at a time over the course of 40 minutes. I think we did one, and then 20 minutes later one, and then 20 minutes later one, so that they would be at different locations and different heights when the totality came by. And we did well. We got all three balloons into totality at a reasonable altitude. But this prediction software, the other one is, this is the real thing, but the prediction software is useful and it's not hard to find. It's online.
Another question. Well, I just had one. You said that there was one where the computer wasn't working. So did you just leave it off the balloon or did it fly and was non-functional?
I think it flew and it was sort of working, as in we got like one data set, but we were supposed to get like seven data sets. In other words, something went wrong. And so it was functional. It knew where it was. It just wasn't getting and logging the data from all of the sensors that were on board. So that was disappointing. That one had been put together by a student who wasn't able to make the trip, and so we really weren't in a position to check it as well as we could have, and probably couldn't have fixed it had we even noticed. I don't think we realized it wasn't working fully because it was sort of working, but that can happen, and you learn something. And unfortunately, with an eclipse, you just don't have the opportunity to turn it around and fly it again in the same environment. This was a very special environment.
But when you plan to have a certain number of pieces of equipment on it, can you at the last minute decide just not to put it on, or you pretty much have to throw everything on and let it
You
go?
can, and so here's one of the things that you have flexibility, okay? And so the idea is you have a balloon, and there are different kinds of balloons, but let's say we use a 1,600-gram balloon, for instance, as a fairly typical size for a weather balloon. And then the idea is if you carry 8 pounds of stuff, then you'll get to 110,000 feet. And if you carry 10 pounds of stuff, you'll get to 100,000 feet before you burst, on average. And if you are going to vent, then make sure you vent before you would burst. Otherwise, it won't help you at all. But yes, indeed, if it turns out at the last minute you just can't fly something, it's not ready, and so you just want to go higher. Well, that's good. Just take it off, and then the whole system will go higher. You get to choose how much lift gas you put in, and the amount of lift gas will change your ascent rate. And so usually we aim for sort of a classic ascent rate of 1,000 feet per minute, 5 meters per second. And so that means to get to 100,000 feet takes 100 minutes, just over an hour and a half. And yeah, it has happened that not usually on the flight line, but like the day before, it's like, nope, that just never got ready. Okay, we will fly without it. And if we fly without it, we will go higher. And if we go higher, then we better rerun our predictions and make sure that we're okay, because that lake that we didn't think we would reach, maybe we're going to reach that lake, and maybe we need to shift our launch site so that we stay clear of it.
And what kind of clearance do you have to get for dealing with local airspace? I mean, I would think that that might be an issue.
Okay, I'm kind of laughing because this is a funny question. It turns out there are rules, and the rules were written in the 1950s. This means the rules are not really up to date. And the people who do drones in particular, they look at us and they say, "You do what? We can't do that." And so, frankly, drones operate under rules, and their rules are much tighter than ours. And at some point, maybe the FAA will get around to changing the rules. But right now, the rules basically say if you weigh less than 12 pounds, we don't care. I call it the turkey rules. It's like if you're no worse for a strike with a plane than a big bird like a turkey, we don't
Hmm.
care. Now, I don't think those are good rules, I will admit, but those are the rules. And so if you fly less than 12 pounds, and we do, you're exempt. And if you're exempt, you don't even have to notify the FAA. On the other hand, for this big, big task where we had many, many, many balloons going up from many, many teams for this whole path, we went out of our way to keep the FAA notified. And so they knew about our flights, and we had cut down devices, at least on the bigger balloons, that they could have called in and told us to terminate a flight, and we would have done so. They didn't do so, and we didn't do so. But in actuality, when I do most ballooning, I don't notify the FAA. I just say, look, I know they don't want me flying near airports. I can deal with that. And they know that I don't have to call them and they can deal with that. And so we kind of agree that I do something reasonable and they don't bother me. Some people call in all their flights, but I've literally had FAA people hang up on me. It's like, you're exempt, don't call. It's like, okay, thanks. Have a good day. Um, so I'm of the camp that there are rules, and if you follow the rules, you should be fine. And I am not, well, here's part of the problem, actually. The FAA in Minneapolis area apparently is more ornery than most parts of the country. And so, more or less, they are not that interested in hearing from me. And I know what they want and I know what they will put up with. And so I do what they want me to do, and I don't usually call them on the phone.
Any other questions? Bob?
Yeah, do you have plans to do any other eclipses in the future?
I don't. It turns out that the next eclipse, I think, is coming up in Iceland or Spain, or maybe it's the same eclipse that goes over both. But pretty much, Space Grant is supposed to stay put, as in, this is Minnesota money that's supposed to pretty much stay in Minnesota. Kind of got special permission to go to Indiana, but I'm not traveling to Iceland. Fun though that might be. So no, I think I'm done eclipse ballooning. I was joking with some people about there is a solar eclipse coming over the Twin Cities in 2099, and they should mark their calendars, but I think I won't be doing any ballooning by that point. On the other hand, I have now seen three eclipses, one in 2017. I went to Nebraska for that one. It was a total eclipse. We did ballooning. One in 2023, an annular eclipse. That was fun, but not nearly the same as a total eclipse. And then, of course, the total eclipse in 2024. Eclipses are great. If you can get to an eclipse, by all means, you should do so. And of course, hope good weather, right? I want good weather for me on the ground, but I sometimes tell people I don't worry as much as some people do because my balloons are going to see it even if I can't. I would like to see it, but my balloons will see it.
So you didn't get the one that went through the middle of the states in, what was it, 2020?
No, 2017. That was the one.
Oh, that was
Where in Nebraska did you go? I was there for that one.
I was in Grand Island. Um, So a little ways into the state, and weather was sort of iffy, but we did fine. On the other hand, just thinking a little bit about eclipses, there was an eclipse. I think the one prior to that, the the total solar eclipse in this country prior to that one was in the 70s. I remember that actually. I was little, but I do remember it. Um, and the 2017 eclipse, which was a coast-to-coast eclipse, which is quite rare. The previous coast-to-coast eclipse was during World War One. Okay, so again, they just don't come around that often, not nearly often enough, as far as I'm concerned. But I remember talking to somebody on one of our phone calls, and she said, "Sorry if I'm breaking up. I'm in the South Pacific." And I said, "Why are you in the South Pacific?" And she said, "There's an eclipse going on. I'm in the South Pacific to watch it." So there definitely are people who go chasing eclipses. I'm not quite in that category, but I've had a pretty good run, and my students have definitely had a good time. It was different students for the two sets of eclipses. On
I
the other
actually think
hand,
I was
ballooning is
at
very
Grand.
cool. You don't have to do eclipse ballooning. Frankly, eclipse ballooning is very niche and very out there. And don't panic if that's not a thing right now, or maybe even ever in your career. I would say ballooning is cool. You should see what you can do.
Yeah, I think I was actually at Grand Island during that eclipse. So we might have been, yeah,
So what
I
I
don't
did in
remember.
that eclipse, which was unusual, is I set up some ground stations in Grand Island. I think they were at the Stuhr Museum. So some of my students were there, but I was with the balloons. And so with the balloons means where I needed to be so I could overfly Grand Island. And so I was literally outside of the eclipse path. I left the eclipse path, I launched the balloons, and then I jumped in my car and I drove back into the eclipse path so that I could experience the total solar eclipse from the ground. But the balloons were already in the air, and then I had students with ground stations trying to do video streaming um, from the Stuhr Museum in Grand Island. My family was in the area. They were driving separately from me. And so they ended up in some parking lot in Grand Island, not because they couldn't get around. It was so much traffic somehow. And then they left. They tried to drive back to Minnesota and they were bumper to bumper traffic all the way back. And I
Yeah.
waited overnight and I came back the next day and the traffic was fine. My
Yep.
impression actually in Indiana was the traffic was not nearly as bad as I thought it might be. But my experience in Nebraska was really bad traffic for a short time after the eclipse was over and everybody wanted to go home. And somehow I just did not notice that when I was in Indianapolis area.
Yeah, I remember the traffic. I mean, we had been staying overnight at somewhere a couple hours away, and we were worried about all that rain that was coming clear across the country that was blocking a whole bunch of the path, and that's how we stumbled. I don't think we intentionally decided to go to that location. We just kind of did it last minute.
Sure.
But
It's
great.
funny
Well,
because I mentioned that some of our teams chose Texas for two reasons. One is because it was a place that two eclipses, 6 months apart, both went to the same place. So that was cool. But also because if you look at historical records of cloud cover and stuff, Texas looked like a good place to watch the eclipse. And it turned out that Texas was a really lousy place to watch the 2024 eclipse. Some of the people who went to Texas were very disappointed on the ground. They got their balloons up, mostly, not quite all, but they mostly got their balloons up, but some people didn't see it at all.
okay. Well, if there are no more questions, like our speaker. Sorry about the delay, and we'll definitely be in touch because we probably need to pick your brain about something that we might want to do here, non-eclipse related, but balloon related. Some ideas we might have. Mike.
That would be fine. I think I've mentioned this to you, but it turns out that there are two outfits, both of which operate out of Indiana. Um, One is called Near Space Launch, and one is called Stratostar. And although they charge money, no doubt, but they will give you good equipment or they will do things for you for a cost. I think it's a great deal to learn to do and to do your own ballooning. But there are people in Indiana who definitely do ballooning and who can advise you better than me or at least more local than me. And so follow up with me, sure. But it turns out there are people much closer than me if you have questions who've done even more flights than I have.
Sounds good. All right, well, thank you so much. Sorry about the delay getting you on, and we'll talk later.
Okay, thank you. Bye.
Thank you.